सही है. So if you're still watching, तो आपको सलाम. Because ये होता है यार वैसे हमसे like I remember पुरानी videos में they start off with 180 views for example, go down, then second part में 50, third part में 10, fourth part में
So I
0.
think
um,
the reason is when someone is guiding you, you get the flow of it, and then you're like, हाँ अब आ गया, अब मैं कर सकता हूँ, अब आगे की चलेंगे.
I think the reason is either people are lazy or we're really bad. But like yeah,
I
वो
refuse to believe the latter. वैसे.
हाँ अब तुम बोलोगे ये मेरी तो पहली वीडियो है तुम्हारे साथ. खैर okay, so let's do this. We have our organic question, a series of reactions starting from 1 bromobutane. And what does 1 bromobutane look like? C, 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 and either Br, right? And you just attach H as needed. So yeah, draw the displayed formula of compound P. So HCN and KCN basically either SN2 reaction हो रहा है, not the SN2 reaction you guys normally look at, but either substitution हो रही है. So instead of Br, the cyanide group would go and attach there. So since you need displayed formula, you draw properly. Like you can't write CH3 here. It's for that structural formula. You have to show and display every single bond, like literally every single bond, which gets kind of tedious, but okay. So this was either normally Br आता था, अभी हम CN कर देंगे. That's what's basically what's happened here. Identify the reagents and conditions. Sorry, yeah.
In this case, if we're making the displayed formula, do we have to show the CN triple bond?
Yes. I forgot. Good scene. Good. Yeah. Do show all bonds. Show all bonds. इधर mark कर देता मेरा. Identify the reagents and conditions for reaction 1 and reaction 2. So reaction 1 में क्या हो रहा है? Basically, okay, so you call this, you can either call this oxidation, you can call this acidic hydrolysis, where your nitrile, if you add dilute HCl here and you reflux this, it oxidizes or hydrolyzes to a carboxylic acid. But I think the preferred term for this is acidic hydrolysis. But reaction 2 को देखो तो but1ene. So you know the double bond बन रहा है, which is basically if it was अगर Br नहीं होता, अगर इधर OH होता, तो that would have been dehydration. Since it's Br, this is an alkyl halide going to an alkene, that is elimination. So what's happening here is you look at this, Br को हम pick कर रहे हैं, Br को हमने चुना, and उसके साथ जो carbon है, so the carbon that Br is attached to, उसके साथ वाला, उधर से we took one H, and these guys formed HBr. सही है, leaving you with this. With this, because this let go of Br, this let go of its H. So this is elimination. You need NaOH, I believe. Is which sharab
in alcoholic condition.
Yeah. So
alcoholic condition. Ethanolic या alcoholic.
Yeah. So alcoholic. इसमें reflux होता है. I can't remember. Alcoholic reflux होता है.
Alcoholic. I think my educated guess would be reflux.
Yeah. But because educated guesses is not the best thing to rely on, so let's say so NaOH and ethanol, well, they don't really care about reflux, unfortunately. But yes, वैसे I would say होता, so that's you have an ethanolic reflux basically.
Can you go back to the marking?
Ethanol. So where
NaOH is that necessary to mention?
If it's a bracket, then it won't cut your mark. If it's a bracket, it won't cut your mark. And a quick tip. So wherever we're talking about alcoholic conditions, so even when we're talking about, let's say, alcoholic NH3 coming and substituting and making an amine, all of that type of stuff, you usually use ethanol. It's a nice sharab. So you can write alcoholic conditions. They prefer that you just write ethanolic conditions or ethanol. So just go ahead with that. So draw the structure of the repeat unit of polymer Q. Polymer Q क्या है? So you have but1ene, जो ये चीज है, and इसको आपने लेके polymer Q बना दिया, which is addition polymerization. So basically what you're going to do, if you look at this, but1ene तो ऐसे है ना, it has this CH2 and this has CH3 like this. You remove one of the bonds, हमने इधर कर लिया, and you just draw another structure of this, because repeat unit, so they want you to draw 2 units. Good? Make sense? Well,
Can you check if a repeat unit needs to have 2 iterations and not just the first repeat unit?
we can check, but to be on the safe
And
side,
you have to
show
the hydrogen as well.
Oh yeah, definitely. I'm just being lazy here. But like yeah,
there's just a single.
हाँ, but like safe side पे रहने के लिए आप बना दो उसमें कोई हर्ज नहीं है. Yeah, oh sorry, इधर आपके पास हाइड्रोजन होगा, इधर भी हाइड्रोजन हो जाएगा, इधर भी आके this will be CH2 basically. So like don't add your hydrogens, like eat your broccoli. Complete the reaction scheme to show the mechanism of the reaction of 1-bromobutane with OH to produce R. Say include all necessary charges, dipoles, lone pairs, and curly arrows, and structure of R. So this is what you're more used to. So we have, this is a primary alkyl halide. They've arranged it in a little funny way, but it's still primary because the carbon जिस पे Br attached है is just attached to one more carbon. Primary alkyl halides आपके पास SN2 हो जाता है. So you should remember the structure, the idea here. So this has slightly negative, this becomes slightly positive. Why is that? Because halogens are highly, they're not highly, not all of them are highly electronegative, but they are electronegative because electronegativity increases left to right. So yeah, because of that, either आपको lone pair बनाना है here. If you have a nucleophile, you should draw the lone pair. This is a very poor attempt of mine to draw the lone pair. I don't know. My stylus seems to, it's not cooperating with me. Wait, let me zoom in further. Yeah, basically दो गोले बनाने हैं आपको ऑक्सीजन के ऊपर, सही है. And from the lone pair, you draw an arrow towards this. Mechanism पूरा दिखाना है. So then let's go to your intermediary step. Intermediary step में क्या scene है? CH2 CH3 की कोई टेंशन नहीं है. You can draw हमने H or H में भी as such इतनी टेंशन नहीं है. But the main thing here is you draw dotted lines to Br and OH. Why do you draw dotted lines? Because this is an intermediary step. It shows that as one bond is being formed, the other bond is being broken. So bond टूट रहा है या बन रहा है. Once you're done with that, you just show properly how CH2 CH. Yeah. Are you asking
You
about
have to show the partial. No, I'm saying you have to draw the partial negative and partial positive sign on the transition state as well.
Slightly positive, slightly negative, slightly negative. So yeah, and then finally हमने कर दिया ये Br की जगह OH आ गया है, बाकी H plus Br negative. And understand, do not forget this, lone pair जरूर दिखाना. Why should you show that? Marking scheme at times has it. The idea here is because it's nucleophilic substitution. So this now is a nucleophile. So nucleophile से ज़्यादा lone pair दिखा दो. And as you can see, इन लोगों ने तो बिल्कुल जहमत नहीं की, इंटरमीडिएट स्टेप भी नहीं दिखाया, बड़े बदतमीज लोग हैं. But like, yeah, I mean, like, but with mechanism again, so I would say draw this, like, because you have to show the mechanism, the proper dikhao. You can't take the risk. So yeah, so but1-ene reacts with steam as shown to form the mixture of two structural isomers. So yeah, so structural isomers, um, and you either major product, minor product, and either
Markovni's rule है नहीं तो
yeah, um, Marconi, but khair.
Marconi.
सही है. So here steam में क्या है? Steam में एक जगह जाके OH अटैच होगा, एक कार्बन पे, दूसरी जगह H अटैच होगा. सही है. And the major, so if I show you the two options, या तो ये हो सकता है, or alternatively if you ignore the red, ये हो सकता है. सही है. And the major product would be that in red, and Hamza will explain why. बहुत eager थे ना.
हाँ, so scene ये होता है कि there are two conditions. Firstly, the hydrogen attaches to the carbon atom which already has a greater number of hydrogen atoms. So if you break the double bond, you notice that the last carbon automatically now has room for 3 hydrogen atoms, right? तो वहाँ पे hydrogen तो ज़्यादा है. और Markovni's rules के हिसाब से the product, the OH, gets attached to the place where there's a more stable carbonium ion form. And as you increase the degree of your carbonium ion, it gets more stable. So the C at the third position is a secondary carbonium ion, so it's automatically more stable.
Yeah, and the last bit is like what I find a little more important, how in the major product is attaching to a secondary carbocation or a carbonium ion, which is more stable. So yeah, so खैर but उन्होंने अब तक तो सवाल तो उन्होंने नहीं पूछा, but identify the type of reaction that occurs when but1-ene reacts with steam. So you can call this hydration, you can call this addition. What do you say, Hamza?
That's with steam. I think hydration. I think it's hydration.
Okay, yeah. Let's just oops type पूछे, right? So थोड़ा सा मैं when the type of reaction may try to be more of the, don't be numbnuts like us, be either say it's oxidation, say it's reduction, say it's an addition. It's what form of addition? So here it was electrophilic addition. And why is that? Yeah, अच्छा, very nice jugaad, like, but I'm sure you guys know this, but like so electrophilic addition आपका ये आपका alkenes में होता है. सही है. Electrophilic substitution आपका aromatic compounds में होता है, but it's not in your AS syllabus. सही है. And nucleophilic substitution that happens in alkyl halides and alcohols and stuff like that. सही है. And nucleophilic addition happens in your carbonyl compounds. So yeah, so like you could literally just remember this and be like, सही है, double bond electrophilic addition हो रहा है. So yeah, but the logical way to look at it is because of the H positive has the first attack, and the first attack is by electrophile, so it's electrophilic addition. State what can be deduced about. Yeah.
I was just adding that generally अगर double bond है, the first thing that comes to mind is कि वहाँ पे high electron density zone होती है. And if there's an attack over there, then it makes sense that something that's positively charged would attack a region which is highly negatively charged.
Yeah, exactly. So state what can be deduced about the structure of S from its reaction with alkaline, aqueous iodide. Iodine. So basically, alkaline.
Iodoform test.
Okay, iodoform test. S है क्या आपका? Major product.
S major product है.
So
देखो अगर उसमें CH3 group added है.
Yeah, so S is this, and yeah, if you really look at this, ये क्या है? ये तो CH3 है आपका. Can we say this is a methyl alcohol, because this is a methyl group attached to the carbon which has the alcohol, right?
Yeah.
So about the structure of S, what can be deduced? Deduced here it is a secondary alcohol or a methyl alcohol. वैसे like structure of S was kind of obvious वैसे, but I don't know, but I'm just want to be sure here. Or methyl, basically structure ये or methyl next to the COH. That's the idea. Or I mean, बोल दो ना, like बोल दो structure बना दो, नहीं differentiate what can be deduced. Okay, but you have the structure right here anyway, so you're good. Explain why S is the major product of the reaction of butene with steam. Okay, so here's what you're gonna do. You're gonna rewind this video. You're gonna listen to all the bakwas we did about why it's a major product, and you're just gonna add it here. So yeah, draw the skeletal formula of S, T, U, and V. S major product tha, T minor product hai. So 4 carbons. Then a 1, 2, 1, 2, 3, 4, and either it will be attaching here. That's S with T. 1, 2, 3, 4, and either हमने OH आ गया. सही है. Just because OH के साथ डंडी निकलती है, that doesn't mean कि एक और कार्बन है. आपका कार्बन फिर भी इधर 4 ही हैं. Like it'll be this, 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 this. These are your carbons. सही है. U का क्या?
काफी common mistake.
हाँ, in fact वो OH additional होता है तो they think they think either people think at times either carbon है, either carbon नहीं है. It's just the OH group.
Just an OH.
So हमने reflux कर दिया with an oxidizing agent. सही है. So basically, and this is S, right? So secondary alcohol की oxidation क्या होती है? Ketone. Right?
Ketone.
Double bonded O. That's it. Write an equation to represent the oxidation of S to U by acidified potassium dichromate. You should use O to represent the oxidizing agent. So yeah, so is ये क्या है? This is CH3 CH2 CHOH CH3 plus oxidizing agent. फिर क्या बना आपका? CH3 CH2 CO CH3. Or if you want to make it a little more clear कि भाई आप इधर ether, वैसे it's kind of obvious ether तो नहीं बन रहा, but like you could, whatever. So CH3 CH blah CH2, मतलब basically CH2 तीन दफा, CO square H is a O square H is a no, don't say square, but like I don't know, दिमाग में square आया था. Hydrogen cube, okay, is a colorless liquid with an unpleasant odor. It reacts with methanol in the presence of an acid to produce an organic compound which has a pleasant fruity smell. So you're giving two hints here. Ek to is an acid and an alcohol reacting, so obviously ester. Secondly, esters do have like a cheese smell and all of that type of stuff. So that's the second hint you have. Name V. Either kya hoga if I just either you have CH3, you have a lot of these groups, and then you have this, and here you just have let me draw this with a different color. In fact, you have CH3OH methanol है ना. सही है. and आपकी esterification हो जाती है. इसका ये this forms H2O, and then the rest of the thing just combines. सही है. So name V. यार Hamza, which side of the chain do you go with? Alcohols first? Is it methyl?
Yeah, you go with, it's methyl.
Okay, so you go with
Convention यही है.
Okay, you go with the alcohol chain first. So that is methyl. And ये कितना है? ये 3 4 5 methyl propyl.
Pentanoate.
Oh no, propyl.
नहीं pentanoate.
My bad.
Alcohol होता है.
Say methyl ester का क्या है?
Pentanoate.
Say it. OH. Yeah, and I don't know, my naming बिल्कुल भूल गया हूँ. Which is bad because like I should know naming. Like A2 में naming आती है, क्या
And
कर रहा
CC
हूँ.
marks.
naming आती है. क्या student analyze.
Yes.
खैर खैर मेरा tenure खत्म हो गया. Methanol and V using infrared spectroscopy, however you pronounce that. The spectra were returned to the student without labels. Identify which of the infrared X, Y, or Z corresponds with V. X, Y, Z के इधर अच्छा नीचे नीचे है. You have this is your you have X, you have Y, you have Z, and they're asking कि कौन सा वाला corresponds with V जो हमने अभी ही ऊपर बनाया है. नहीं V हाँ V एस्टर ही है ना. So V का क्या सीन है. V has C double bond, C carbon is double bonded to oxygen, it has that. CO भी है. So let's check इधर क्या है. You have a so 1500 तक तो fingerprint region होता है if I remember correctly, right?
हाँ 15.
So like
But it ऊपर जाओ question.
in the region
It
above.
says red
Yeah.
1500. उसने खुद ही बता दिया.
हाँ इसलिए like if you don't know it, because 1500 में फिर like बहुत peaks आ
Yeah,
जाएंगी. So yeah,
yeah,
so
yeah.
here ये इधर एक peak है. I mean it's a little tough to go through all of these. So let's just look at what peaks we could be expecting from our data booklet. मैं कोई literally जैसे एक साल बाद infrared कर रहा हूँ. इधर
Well, it's
infrared
pretty
ये
easy वैसे.
yeah. Condescending, but whatever. So yeah, so
But you just have to analyze a
so yeah,
set of values though.
so
Yeah.
we do need C double bond O. In fact, हमें ester वाला चाहिए तो around about 710 to 750. You need a strong peak. ये क्या था 1710 to 1750. So why can't be it? Because इधर 1700 1700 पे कोई peak नहीं है. X and Z can be because they have a peak around the 1700 mark. So okay, they're in the running. And let's see what else we can judge. CO ये देख सकते हैं जो एस्टर्स के पास भी होता है. एंड दिस इज बट ये फिंगरप्रिंट रीजन में आ गया.
It's outside of the region. आप तो last वाले पे जाओ.
Yeah.
Carboxylic.
But अभी तो carboxylic नहीं होगा ना. Because are we looking at V? Yeah, we're looking at V. So
we're looking at V.
V is an ester. So let's just go back. What else can we see? CH alkenes. Can't believe it. There's a strong peak around 2950 if it's an alkene. If it's an alkane. 2950 pe. Well, this is definitely a. I don't think this is a strong peak. I mean, this is a.
Yeah. The first one you said was strong.
Yeah. So
आखिरी वाली काफी strong
if
है.
we can call this a
I think
weak.
Prexo.
Z over X. So Z. We're looking for a strong peak, right? Are we looking for?
नहीं, but a strong peak suggests a carboxylic or an OH group, na?
Strong. Okay, so strong and very broad. Okay, so the important thing here is very broad. So if it's strong and very broad around the 3000 region, which in fact this exactly is, it's strong beer, broad beer. So yeah, then you can say that Z probably contains a carboxylic group. So yeah, which is not what we want. In fact, the only reason we might have a peak around the 2950 region is because of the alkane wali cheese. So I don't know. So with that, we conclude with X. So yeah, and let's just get some validation. So it's X.
Yeah, X.
So yeah, and iski the
Oh,
way
you have to explain it too.
Oh yeah, you definitely do. Like I just want to explanation that are marking schemes हम देख लेते हैं because it's easier just to explain with some visual cues. So now ये तो हमने discuss किया था you know, X and Z, they have C double bond O 7, you know, around the 1700 mark, and that is true for esters. So that is how we in fact eliminated Y. So you just basically put that stuff like that into words. So, and now the way they've gone about, they're like Y and Z show OH stretches above 2500. Y and Z show, एंड बाय दैट दे मीन इधर भी अगर आप कार्बोक्सिलिक को भी देखो, व्हाट इज, हमने कार्बोक्सिलिक का क्या देखा था, OH ही है ना, but here it's like it's OH bonded to a carbon that has double bond, so carboxylic wala. So the idea here is, you can still call it an OH stretch, that they're giving you a broad peaks, इधर भी इसमें भी broad peak है, इसमें भी काफी strong and broad peak है, and that doesn't happen with your alkane. alkane में तो इतनी चुन्नी से बिचाया है कि बस यही बनता है. So strong and broad peak है, so that is something that you definitely do not have. Whether it has this, it does not have OH group, it does not have a carboxylic. Carboxylic में भी OH तो होता है ना, none of that. So that's the idea why you can, by elimination, you can prove that it is X.